it's James from Technical Topics. I'm here today to show you my latest video, which is on a 2007 Audi A4 2-litre TFSI. So it's a direct petrol injection turbocharged A4. It's a cabriolet, not that that affects the diagnosis. And this car is presented with a symptom of limited operation mode, sort of limp mode. Customers complaining of the revs aren't topping out, so it's getting to about 3,500 RPM. There's a funny noise from the exhaust, and the car performs probably quarter speed. It's maxing out at 40 to 45 miles an hour. The problem with the vehicle is intermittent, so it doesn't happen all the time. It tends to be upon startup, and there's some irregularity with the light, so the engine management ESP light. If the ESP light comes on during cranking and stays on once the vehicle's running, it's in limp mode. If it doesn't, the car performs okay. It's happening sort of irregularly, but every maybe few days it will do this thing. Sometimes you switch the key off, switch it back on again, and the car is fine. Other times it just takes time to clear itself, but it does need a cycle of the ignition. We're going to use the Arboretus ABDI and their software to interrogate the vehicle, and we're going to firstly look at if there are any diagnostic trouble codes stored in whichever systems, and then we're going to look at the codes, try and form a process of elimination, run through whatever checks and tests that we need to hopefully get to a conclusion with this job. This may involve the scan tool, the oscilloscope handle, multimeter, and some wiring diagrams. I'm hopeful we can run through a process and try and establish a root cause. Okay, so I'm going to log into the Audi software, and let's interrogate the units that are involved with the functions that we've got an issue with. So ESP and engine management. The symptom is obviously loss of power and these two lights coming on. So we're going to take a look at engine control unit master. We're going to dive in there and read the trouble codes. Okay, and what we can see from the trouble codes that we've got there are fuel pressure regulator valve open, or open circuit open for evap, turbocharger bypass control circuit malfunction open circuit, and solenoid valve for boost pressure, and also oxygen sensor bank 1 sensor 1 heating circuit malfunction. So interesting, when we have a cluster of these fault codes like this, it's important probably early doors to see if we can work out some common connection. So there could be a common wire, a common fuse, a common link, a common splice in the loom, or something that enables us to try and work out the root cause, because it's unlikely that all of these devices have failed in one go. You never know, never say never, but it's more likely that there's something common that's affecting all of those things. Next step, we'll have a look at ABS, and in ABS we'll dive in there and read the trouble codes, and ESP ABS has no faults stored. So customers complain of engine malfunction in terms of power reduction and ESP light coming on. Well, the ESP doesn't have a fault. We've got 5 in engine unit master. In this case, we could do a quick visual inspection around, but pretty early on we want to be looking at the wiring diagram and see if we've got anything that is common between those things. So in the background I've logged into the Volkswagen Audi software. Let's have a quick look, and I've put the VIN number in, and I'm going to take a look at workshop wiring diagrams. So if I fire in here to workshop wiring diagrams, we should find current flow diagrams over here, and in current flow diagrams we're looking for 2-litre TFSI. We've got engine management related faults, and what you'll see is each one in the Volkswagen Audi software called Irwin, we've got listed by function then all of the key components. So they generally cluster by function several components on one diagram, which makes it easier than looking through pages and pages. So we can see firstly battery starter, and they normally start with power supply and then control units, and then go through the sensors and actuators. We can see engine controls, current supply, injectors, and here look on page 5, charge pressure control solenoid, valve and active something else, and also then lambda probes on page 6. So let's have a quick look at page 5. If we open up page 5, it should give us a description. I'm just going to shrink back the index page, and then we can see in more detail what we've got by way of a component diagram there. So we can see charge pressure control solenoid, active charcoal filter, that's the evap, control units on there, turbocharger recirculation, fuel pressure regulating, fuel metering valve. These are the same things, but I think they depend on what we're looking at. They depend on the engine build probably. So here we have engine control unit, and then here we have some solenoids across the middle. I'm just looking through the diagram. There's a fuse there. So let's take a quick look at the diagram as we've got it. These are the components that we've got. N75, we've got charge pressure control. N80, we've got activated charcoal, that's the EVAP. N249, we've got here is turbocharged recirculation. 290 or 276, there's a little double asterisk here, which if we go down here says, is replaced by N290 on systems with the diagnostic pump. So they're my 4 components. We've got 5 faults, remember. We've also got an oxygen sensor, but these are the 4 common tied together components that have come up. Now, if we look, okay, so these are my ground wires. So if I draw a colour in for ground wires, let's draw purple for ground. These are my control wires going back to the engine control unit. And let's have a look at the supply. And the supply wire then is coming down to a splice, down to a splice, down to a splice, down to a splice. If I just draw that in there, here's my other splice, and up to a fuse. S345, which is a fuse, if we have a look here, S345 engine electronic fuse number 3, and there's a little location shown by that camera picture there, which we can work out where that is. So this is one thing that ties and is common to those 4 components, which is really interesting. If we think about potential fault scenarios, okay, my engine control unit here could be dead, but if it was dead altogether, I think there would probably be either no code stored depending on how it died, if you lost a power or a ground, or if it was potentially faults on each one of these driver circuits. And if we think about what's inside the ECU here, we've got a transistor, we're showing it here, but there's a transistor here, transistor here, transistor here, transistor here. So we'd have to lose 4 transistors to flag those codes. It's sporadic and intermittent. Is that likely to lose 4 transistors? Maybe, and 5 if you include the one on the heater circuit for the oxygen sensor. It's probably quite unlikely. Okay, next scenario then. Do we have a short circuit on one of the grounds? So one of the control wires that goes to the solenoids, they could be pulling to ground. Hang on a minute. That would do what the engine ECU does, but it would overwork. So instead of controlling it on and off as most of these things do, it would pull it to ground all the time. If you pulled it to ground all the time, could that affect all of the other sensors, all of the other actuators? Well, it's unlikely because they're all common wires. They're all uncommon wires. They're all separate wires to each of these components. So you'd need 4 short circuits, or 5 if you include the oxygen sensor heater, which again is unlikely. What is common? Okay, so each of the control wires aren't common. What is common then is my supply side. So this is a good theory. If we lost either open circuit there, okay, the supply, so we lost the supply to these devices, they would all stop functioning. ECU would detect that they weren't functioning correctly and would set a fault code. But we could then have an intermittent open circuit on the supply. Yeah, that's possible. The other fault that we're likely to see on a wire, because we've either got short or open or too much resistance, you could have a resistance fault. Sporadic resistance, well, probably a sporadic open circuit would be good, but a sporadic resistance of high resistance is unlikely. But you never know. So that's one potential thing. But if we had a short, let's say, to ground, and we were blowing that fuse, the fuse would permanently be blown and the faults were permanent. This isn't what happens. The faults on these cars are intermittent and sporadic. Okay, it could be a short intermittent, yeah, but why isn't it blowing the fuse? If you have a current draw after the fuse that's due to a short to ground, it will burst the fuse, and the fuse will have to be replaced before you could reset the faults. That isn't the behaviour this vehicle is exhibiting. This is an ignition cycle, off and back on again, and very often the fault will clear and the car will be okay. So we have got something common, but it's unlikely to be a fuse related issue because the fuse potentially would be blown all the time. Oh, you could have a resistance in the fuse, you could have a resistance across the fuse, yeah you could, but these resistances generally when they build up through and it's normally water ingress, are permanent resistance. So if you had water in this place, it would go rusty and the resistance would be high all the time, and the supply to these devices would potentially be high all the time. But it's worth checking out. Something in our things that it might be. We don't think it's going to be a ground problem. It could be a supply problem, and it could be after the fuse. The other thing that we've got to think of then is perhaps it's before the fuse. If we understand where the supply to that fuse comes from, it could be worth checking that. With the Volkswagen Audi diagrams, I'm going to scroll down a bit, so all my scribblings will have to be moved now because they don't scroll with the screen. what we've got here is a number 16, and number 16 in Volkswagen Audi land, they have columns. So across the bottom of each of their pages we've got a column, and those columns are given a notation. So we've got 43 there, 44, 45, 46. What we can see in this column 43, we've got a link to number 16, and if we go to the column 16 we will see a box like that with 43, and that will join those two wires together. That will, if we can get there, show us where the supply comes for that fuse that supplies 4 out of my 5 dodgy components. So we're going to scroll up the page till we find number 16, and there we go. There's row 16, or column 16, and in there, look, we have 43. So that is where the supply comes to my fuse, and it also supplies something else. So this is my questionable one, and there could be a little question mark under that one there. What's being supplied there? This fuse J757 is engine components current supply relay. Oh, that's an interesting one. So that's supplying engine components. So with a relay, as you probably are aware, we've got a control side here. Let's write that in purple. Let's scroll up a bit actually and redo that. With a control side there, and that's controlled, look, by potentially ECU. So the ECU is controlling the switching of that particular relay. And then if we think about the input side, we got terminal 30. So this is hot, and that's coming from actually, and it's also supplying other things. That's probably coming from a 6mm wire. So 6.0 equals a 6mm wire. It's a big fat chunky wire coming from an ignition switch or another relay. Okay, could we have a problem with this one here? Not supplying the input? Yes, we could. What other things would we see? Okay, if we lost that big supply there, we would lose signals to this fuse, this relay, and the control unit. And this J271, I think, is the main relay for the engine management system. It's providing, and actually that's providing a supply to a whole host of other stuff. So if we lost that relay, I would expect, because we lost that supply, let's say, I would expect we would have lost many, many other things. And we can see that that's main relay supplying a whole heap of stuff. So if we suspected a fault at that point, that could be the case. So we had supply to all of this stuff, but not to our relay. That's a potential. So that could be our root cause. Other faults we could have, well, we could have a problem with the switch side, so we could lose the input or the ground to the relay on the control side, or we could have a problem with the switch itself, so the switch could have a problem, or we could have an open circuit in this wire that supplies these 2 pins. So 43 is the one we looked at, but that also supplies another, which is 57. This could be a root cause. It could be wherever that's going to G. It could be after that, of course. But what we do see, D50, that's a positive connection splice in the engine wire harness. So a big fat 6mm wire goes into the loom and it spreads off. A 4mm wire, and then a 1mm wire, half-mil wire, 1mm wire, 4mm wire. So these are supplying these other devices. So looking at that diagram, we could have that situation. We could have a control side, we could have a switch side, we could have an open circuit in either of these two. But what I don't think is, I don't think we have a problem here. So with all this red stuff, I don't think that's a potential issue. Could be control side, could be in the relay. But at the moment, 4 of our faulty components live off this pin. Let's just for a second check to see where 57 goes. So let's clean the screen. 57 goes to 17. So let's scroll down to 57. If we find a box with 17 on it, let's have a look. Okay, 57. There's 57, there's 17. That's supplying another fuse into a splice. Lo and behold, okay, it goes in here. Oh, and in here. So we've got 2 components here. Oxygen sensor, oxygen sensor. This is a TFSI, so it's a direct petrol injection. So we've got 1, 2, 3, 4, 5 or 6 wires on our oxygen sensor. So that's a wideband sensor on the front. This is a narrowband sensor on the back. But the other side of that relay controls the 2 heater circuits, one of which, and I think it's this one, we have a malfunction. We have a DTC for this. So looks like we've got either a relay fault or output from the relay, as we described in the previous diagram, which is affecting these common components. So I don't think it's any of these supplies after the fuse. I don't think it's here, but if we go back to the other diagram, it looks like we need to focus on that fuse which is supplying the controls, because all of my faults and troubles emanate or seem to come from this one relay here, J757. What we have to do now is work out where that relay is and probably open up the relay or the box where that lives, and maybe try and get into the back of that relay and just check out its function. And we should be able to diagnose then a root cause behind the problem. Have we lost a supply? Have we lost a ground? Have we lost an input? Have we lost the output? And we should try and be able to work out what's going on. Very usefully in the Volkswagen Audi diagrams, we've got, if we look at J757, engine component current supply relay. If I click on that picture of the camera, it should take me through to a link. Get my scribbles off there. Relay carrier 4-pin for the components, location for petrol engines. So we've got a BWE engine. So if we click on that page there, the hyperlink, BWE, it should take us through to a component location. BWE from November 2005, that's our car. Starter inhibitor, that's for automatics, we won't have that because ours is manual. Motronic current supply relay 271, that's the big one that supplied all of that other stuff. Engine component current supply relay 757, so we've got relay 2, relay 3 in the fuse box, which lives in electronics box in the plenum chamber. If we go back a page, it should maybe give us positions of relays and fuses. What did we say? J757, so let's have a look. I think it just took us there, didn't it? 757. Sometimes it gives us an arrow located on the car, and I think it did before we clicked in. Okay, so relay carrier 4. So this is for left-hand drive cars. We drive on the right side in this country, so we have to swap that over, steering wheel on the other side, and potentially that 4 will be on the other side as well, but we'll have a look both sides. There's no major drama. What we'll have to do is a bit of strip and fit, because on this model we have to take the windscreen wipers off, and then there's a trim panel above where the battery and all the electronics live. So we'll take that off, and I'll switch over, move the camera when we're in that position. We can take a look and see what we can find. Okay, so I've got the trim panels off and the wipers off, and we've uncovered the trim panel. Over that side is the battery, and there's a pollen filter, and this side then is what they're calling the plenum. There's a plastic box. I've taken the cover off, and now I'm going to take this small clip off, and under here we should find living a set of relays. So I'm just going to clip that, push this clip down, unclip. Easier said than done. We should be able to clip that one back up. There we go. Pull that clip off, that secures the ECU, and then as we lift the ECU out, we're going to look for anything nasty. Now all the main wiring loom goes through here, runs across to the engine, and then down below, in there, in below, we have got our relay carrier. So I'm just going to get the relay carrier out. I'll move the camera to a slightly better position so we can see what's going on, and then we'll try and run some tests. I'll just lay this ECU here so it doesn't fall short out. There we go. Okay, so I've got a light up above here, and I'm going to pull this relay carrier out. It's held in with a small clip, and what we can find are two relays, 614 and 614. And if we remember back to our diagram, I'm sort of a little bit worried. There's some signs that relay's been out before, and in fact this car has had two other repair attempts made on it, and it's had, the lady said, various components being fitted. So I think some solenoids and some sensors. So this could be something to do with the fault that we've got. I had a quick look round, and it's been ongoing, this fault, the lady says, for about 3 years. So there's no sign of anything new as I did my visual, but she has had some attempts at repair being done. If I go to the back of the relay carrier, what we can see, and in terms of confirming the position of the relays, we've got two relay carriers. The heavy duty current carrying wires are red and red with a grey trace, and on the other one they're red with green. So what I'm going to do is just going to flick back to the diagram here a sec. Flip back to the diagram, back. Because the position of the relay holder can sometimes be slightly dubious, that you're not quite sure if the relay was this way or this way. But by looking at the wiring colours, we should be able to define exactly what we've got there. I'm just going to scroll down to the page, and in fact, let's have a look. Our wires coming out of that component supply relay are green. So we have a red wire going in 4 mil and a green 4 mil wire coming out the other side. So let's identify the correct wire. Let's grab the jolly